continue with some further examples based on fundamental laws and whatever we learned. Find out the current in the middle 30 ohm resistor. Find out current in the middle 30 ohm resistor. So let us call I1. Find out the current I1 in the middle 30 ohm resistor. So we can suitably name the other currents. So I will give some hint, and based on that you can work further. We again use Kirchhoff's node law, Kirchhoff's first law or Kirchhoff's current law for defining some current which we are not knowing yet. So this is I1 which we do not know. Let this be I2 and let this be I3. Correct? Let this be I1, let this be I2, let this be I3. So you can very easily find out the other currents. What this would be? This would be I2 minus I1, and this would be I3 plus I1. Is it correct now? It's alright. So Kirchhoff's node law or first law provides us a very simple solution that way, means it is allowing us. Otherwise what will happen? Otherwise there are how many arms independent? 1, 2, 3, 4, 5. So you have to presume 5 currents, I1, I2, I3, I4, I5, and then apply Kirchhoff's node laws. Then you can reduce some equations. So that we do not do. We immediately use the laws to define the currents. Is it clear? The first thing is that when there are 5 arms, there will be 5 currents. So I1, I2, I3, I4, I5 you can assume, and then you can apply Kirchhoff's laws to express one in terms of the other, which both of these steps we have applied at once here. Now Kirchhoff's mesh law is to be applied. Kirchhoff's mesh law is to be applied. There are many loops now which you can work, but better to take the loop in which we have voltage source. If we do not have voltage source in a particular loop, what is to be done we shall see, because a need has arisen for that also. So first loop is this loop, second loop is this loop. 2 loops you can take. You can write 2 equations. What those are? First is 10 is equal to 10 I2 plus 5 into bracket I2 minus I1. Correct? Any difficulty? I will not go on simplifying the equations. Solution of 1 or 2 or 3 or more simultaneous equations is a high school level task. So we will just write the equations, leave rest of the things to you. Then second would be again 10 is equal to 20I3 plus 5 into bracket I3 plus I1. Because our logic is voltage, battery voltage equal to voltage drop. That is logic, right? In Kirchhoff's mesh law, there might be some difficulty for you. You took a loop with this 10. So you take this on one side and start from positive end of the battery. Logic is you take this 10 on one side and for writing on the other side, you start from positive end of the battery and go in a particular direction from positive end to negative end by covering all the arms containing resistances in between. And when you are traveling in a particular direction, if you are traveling in the direction of the current, you take this drop as positive. So 10I2 you directly take. 5 into I2 minus I1 you directly take. Even the reverse means if the current is flowing like this and you are traveling like this, then drop you consider as negative. So voltage source equal to voltage drop. Or algebraic the voltage across the loop is 0. Now a situation which we were avoiding till now has come. There is a situation like this now. We have to, both loops are over which contain voltage source. For solving three simultaneous equations, we need one more equation. For that purpose, we have to take a loop which will not be having any battery as such. Which will not be having any battery as such. Right? So, we will take, say, either this loop, or if we take this loop, then there is a very simple thing. What is our logic? Battery voltage equal to voltage drop. Is there any battery? No. So battery voltage is 0. Then you can start from any point. See to it that you come till that point. That's all. You can start from any point, come till that point. So 0 is equal to. Suppose if you start from here, 0 is equal to. How will you start now? What is this? Current is I2 minus I1 into 5, but in which way? It will minus because you are traveling this way and current is in this way. I2 minus I1 is assumed in this way and you are traveling reverse. So 0 is equal to minus into bracket 5 I2 minus I1. What about this? Plus. Why? Because your direction and current directions are same. Plus 30 I1 plus 5 into bracket I3 plus I1. So three simultaneous equations are available. And three unknowns are there. I do not find any problem now. These are solvable and you must give an answer. Express one in terms of other somehow, have suitable substitution and then proceed. Is it clear now? I think you can leave some space. Maybe at home you can find some time to solve the problem. For our subject, you must prepare a separate notebook. I think I will rub it out now. We will start a new problem. find voltage at point B or find VBD. Find VBD. We are now working with a current source. We had made yesterday very clear that a voltage source is that entity which somehow maintains a fixed voltage across it. Current source is that entity which somehow maintains a fixed current being driven by it. Voltage source, one more very simple working definition we can have. Voltage source can supply any current and current source can have any voltage across it. Voltage source can supply any current as demanded by the remaining system out of it, and current source can allow any voltage to be developed across it, again depending upon the system to which it is connected. I again repeat, a voltage source is having some voltage as its value. So a 5-volt voltage source can deliver any current depending upon what circuit you connect. Say 2 ampere current source, any voltage can develop across it depending upon what system you can connect. So for current source, current driven by it is fixed, voltage may vary depending upon the system. For voltage source, voltage given by it across that source is fixed, current given by it can be anything depending upon the system which you have connected. So with this now, how will you proceed? We have to find voltage. We have to find voltage. So for finding voltage, the voltage can be found very easily in this case. But let us keep a practice of writing standard equations by defining currents in the arms, and solving them. So what would be? Choose first arm. Let this current be I1. Let this current be I1. Fortunately, we get a solution easily here. What is this current? This current is 1 because it is connected to a current source. So what this current would be? I1 plus, correct? I1 plus 1. Right? And then apply Kirchhoff's second law. One simple thing which you should take it for noting is that the Kirchhoff's mesh law cannot be used for a loop which contains a current source. Means Kirchhoff's mesh law cannot be applied across a loop which contains a current source. So that is not counted as a loop for applying Kirchhoff's mesh law. So you can apply Kirchhoff's mesh law for this loop. So what it would be then? 20 is equal to 5I1 plus 20 into bracket I1 plus 1. So that is equal to 25I1 plus 20 is equal to is it correct? 20 is equal to 5I1, 20 is equal to 5I1 plus 20 into bracket I1 plus 1. So 5I1 plus 25I1 plus 20. I1 is equal to 0. I1 is equal to 0. So when I1 is equal to 0, what would be voltage VB? When I1 is 0, voltage VB must be 20 volts. Voltage VB must be 20 volts. I1 equal to 0. Therefore, this must be equal to this voltage. Let us make some minor change. We make some small change in the problem statement. V equal to 45 volts. V equal to 45 volts. So what would be I1 now? Simple one thing changes here. Then this becomes 45. This becomes 45. So I1 equal to 1. I1 equal to 1. So when I1 is equal to 1, what this would be? When I1 is equal to 1, this would be 40. Is it clear? Or do you have any difficulty? So by Kirchhoff's node and mesh analysis, it is possible to solve any problem. But what happens is that method is somewhat time consuming. Nowadays with computers, these issues have not remained so significant. But still one can say that this method is somewhat time consuming and complex. Therefore, few centuries back, Thevenin was thinking on some other lines. And now, whether anybody is exposed to Thevenin's theorem first? Have you gone through Thevenin's theorem? Yes or no? At least in any course study you have not gone. Those who might have gone through Thevenin's theorem by looking at the syllabus of the second year when you have finished first year examination, for such exceptions, we would not like to comment, but you have, usually you have not gone. So, let us try to work on Thevenin's theorem. Let us try to think like what Thevenin has thought. Let us try to think what Thevenin has thought. So, we take a very simple problem. So, this is a box. The things inside are like this. And you connect resistors across it. This is point maybe is A, this is C, and this is B. I'm just drawing one inside, one outside. This would be same point as C. This would be same point as B only. Now the question is, what would be VBC? What would be VBC? How you calculate the voltage, or what would be this current? That by standard Kirchhoff's laws you can solve this problem. By standard Kirchhoff's laws you can solve this problem. This is one case. We may go for second case. These points are available, and again you have option to connect some resistor. So you may connect. If you connect 25 ohm resistor here, how much current will flow to this resistor? What will be voltage across this? So again, as I had already stated, you can find the same answer by using Kirchhoff's laws. But each time when you change the resistor, you rewrite all the equations. Each time when you change this resistor, you rewrite all these. What is changing now? Only this is changing. Other things are constant. Only this is changing. Other things are constant. Each time when you change this value, you rewrite Kirchhoff's laws equations each time and find out the answer. Then Thevenin at one point of time was thinking on this issue. His way of thinking was, ultimately whatever is inside, so this is one case, and there is one more case like this. So three cases, case 1, case 2 and case 3, and each time what is common? 2 points are coming out. In each of the system, 2 points are coming out. I will not name the points right now. So, which is simple to handle? Most simple? That one, right? Then maybe this one, and then maybe this one. Is it clear? So, what we are having, 2 points have come out of a system. Inside the system there are voltage sources, maybe current source also, to that we shall come later, and resistances. A network consisting of resistances and sources is there, from which 2 points are coming out, and I want to find out what will happen if I connect some resistance across those 2 points, how much current flow. So here this is simple, this is difficult, it is complex. So Thevenin was thinking. Ultimately, for me there are only 2 points. For me there are only 2 points. Then Thevenin asked the question to himself. First of all, can you? There are two issues. First is, if you are able to find out what question you should ask yourself and then solve, it is more appropriate. Then by my hinting of these many things, whether do I find a mini Thevenin in this class who is able to turn the same question which Thevenin has asked himself? Is it there? You seem to be mini Thevenin. What is the question? The question is, can I look? I am looking. So first of all, what I should do? I should remove these. This I have connected. So it is yet not connected. So I remove these points. So what I have? I only have 2 points which have come out from the electrical circuit inside, and I am looking it in this way. Out of this, what is simple? This is simple. This is complex. So the logic of all those who try to learn something to make the simple things complicated. Is it right? Why do we learn? To make simple things complicated, or it's reverse? To make complicated things simple. So Thevenin was asking a question. Can I see something like that here? Are you getting me? Here there is something which is much larger. Can I see something like that here? Because in 2 points means what is this can be equivalently represented by this. So this circuit is equivalent to a Thevenin's equivalent circuit where these would be determined. For this circuit, there will be some VTH and some RTH. So I decide that it should, I prima facie feel that it should be possible that these 2 points, when I look towards circuit from these 2 points, looking, because other points are not accessible to me. Other points are not accessible to me. So when other points are not accessible to me, my interface with this circuit is only through these points. So when my interface is only through these 2 points, then this circuit should look like as this circuit for me. This I should be able to view inside this as if I am viewing this. So any between 2 points, when I can choose any 2 points, whatever is the complex circuit, I can choose any 2 points and I can look towards the entire circuit through these 2 points. And when I look towards the entire circuit through these 2 points, I look a very simple thing inside and not a complex thing. The simple thing which I look is one voltage source and one resistor. Thevenin has provided us a technique by which I can view any complex circuit between 2 points to be a very simple circuit comprised of a voltage source and a resistor. Now the question is, what is the voltage source? For this there is no question. It is like Thevenin's only. So 10 volt and 10 ohm. No further reduction is needed. For this, let us say now, Let us try to find without studying Thevenin's theorem. If Thevenin's theorem is stated, then you are finding it mechanically. Without stating Thevenin's theorem, we try to find out Thevenin's equivalent circuit for this. Let's start. Means, or we should be drawing. I will draw it up. This should be electrically equivalent to this is RTH, sorry, this is VTH. What do you find out? This is RTH.
30 volt and 20 ohm.
Answer is
30 volt and 20 ohm.
30 volt and 20 ohm. This is 30 volt.
Yes.
This is 20 ohm.
Yes.
If you take a voltmeter and measure this voltage, how much it will come? And if you measure this, how much it will come? So just now, rather than answering spontaneously, you should work something and come to a solution. I give the hints. Short circuit and open circuit are the hints. Short circuit and open circuit are the hints given. You work and find out the answer. When these are equivalent, whatever thing you observe by connecting something in between here, same thing should be observed by connecting the same thing here. Connecting nothing is also connecting something. Connecting nothing is open circuit. Connecting a wire is short circuit. So try to equate voltage and current in these two things. I think that I had sufficiently hinted and we should get an answer. What is the answer? 15 volt and 5 ohms. 15 volt and 5 ohms is the answer. Volt and 5 ohm. How did you find this answer? Why 15 volt?
Because the two resistors are in parallel
So,
to each other.
Then,
So it's
where you see them parallel?
because the voltage across the 10 ohm resistor is to be found there.
The answer is simple. Consider open circuit case. Means don't connect anything. What voltage is giving? 15 volts. The same if you don't connect anything, to have 15 volts here, this must be 15 volts. This must be 15 volts. Then connect a short. Connect a short. How much current will flow? How much current will flow through this arm? How much? 3 amps, because 30 upon 10, 3 amps. So we have found out this to be 15. This is not yet found. Can I be short? What this must be? What this must be? For this to be 3 amperes, what this must be? 5 ohms. And then that's all. Is it clear? So this is the equivalent circuit, Thevenin's equivalent circuit. Now go for this. Now go for this. At least VTH you should be immediately finding. VTH you must be able to find immediately. RTH you will find difficulties. What is VTH? VTH is 5 volts, right? Because for open circuit, what is VA? 50. What is VB? What is VB? Is 10, 5, so 1/3 is 15 and 10, so it is 5. So this must be 5. This must be 5 volts. For RTH there is some problem to find. What will be short circuit current? How will you find short circuit current there? How will you find short circuit current there? So to find RTH, you have to find the short circuit current, and then for this VTH, for short circuit to give that much current, you have to get the RTH. So how will you find short circuit current now? Let us try to find. Okay. So let this be I1, right? Let this be I2. Okay. What this is? What this would be? Let this be now ISC, I short circuit. In which way we have presumed? We have presumed in this way because it is by common sense. So what this would be? I1 minus IC. And what this would be? I2 plus IC. Then write the equations. Write the equation and find IC. Write the equations and find IC. So what is the answer? Anybody got the answer? This is 5. for a while. So you got the answer? What is the answer? Total answer. RTH is, or current is 3 point. Any answer? So we find that we are traveling in the reverse direction now. Means, what is the reason? We are learning to simplify the complex things. But here we are finding that to find RTH we have to find ISC. And if ever I have to find ISC, in that case, by the same complex way, what is the purpose of finding the equivalent circuit? So, we can think in some different way. First is alright. For open circuit, VTH can be found very easily. That's not a problem. VTH can be found very easily. That's not a problem. Now RTH is to be found out. Can you suggest some alternative method for finding RTH? Can you suggest some alternative method for finding RTH? I give you a hint. I am looking from this. Both should be equivalent. I do not know what is inside there. I found out this voltage by finding open circuit voltage here. At open circuit condition, both should be same. Now, there may be some voltage sources inside. Now, if I decide, I am trying my level best now to simplify the system. It is simplified in this manner. So, I find out a zero source Thevenin circuit equivalent. What is zero source Thevenin circuit equivalent? This voltage source is made to zero. So, what zero source Thevenin circuit equivalent should look like? What zero source Thevenin's equivalent circuit should look like? This must be zero. Since all voltage sources you have made zero, this must be 0. This must be 0. So when this is 0, like this, and you should look only resistor. You should look only resistor. So when you make voltage source is 0, what happens? Voltage 0 means these two are same. So when you go on reducing the voltage source, a voltage source sourcing 0 volts is a short. A voltage source sourcing 0 volts is a short. Then you find the equivalent resistance. Then when you look it from this now, what you look? Simply a resistive network. Means this I can draw here and I can look from this. So I can redraw it. This is point A, this is 10, this is 10, this is 10, this is 5. So it is a short. So 10 parallel 10, which is 5, plus 10 parallel 5. What is 10 parallel 5? It is
50 by 50.
5 by. So 5 plus 5 by 3, that is 25.
10 by 3.
10 by, it is 5, right? It is 10 by 3. So 5 plus 10 by 3 is 25 by 3. And then this, what I see here, so 25 by 3. And I have not actually made the voltage source 0. So whatever VTH I have found earlier happens to be here. So I find VTH by open circuit voltage. I find VTH by open circuit voltage, and I find RTH to be the effective resistance between the terminals by shorting the voltage sources. By shorting the voltage source. Right? So Thevenin's equivalence, Thevenin's looks one voltage source and one resistor for any circuit consisting of resistors and voltage sources. The voltage of the Thevenin's equivalent model is you found out by open circuit voltage between these 2 points, and the equivalent resistance RTH is to be found by the resistor by shorting the voltage sources. By shorting the voltage sources. Is it correct? Which next section? And when is the tutorial today? Show me the timetable. When is tutorial? Timetable. Timetable. Be quick. Right. So at 2:15 today we will be engaging, right? We will be engaging at 2:15 today for corresponding mathematics section. It will